L'Hopital's rule. Apparently he's a French guy. His name Trent.
My mom got it from like a student and I snatched it.
That's not one of those Lily Pulitzer ones, is it?
No, it
Oh,
wasn't.
never
Luke
mind.
was giving me crap about the color of it, but like.
It's like an olive.
Looks like green
He
rock.
said it looks, thank you, he said it looks like,
Oh no!
It looks like what?
fenced off. I think it's.
Whenever there's a. Oh, you
Anyway, all right, here we go. So, L'Hopital, French guy, whose name literally translates to the hospital. And he came up with a fairly interesting theorem, which when I give you that theorem, the first thing you're going to ask yourself is, why didn't we do this a long time ago? And my response will be, I don't know. So, we are going to look at something called indeterminate forms. Let me give you the theorem first. Hold on. Here we go. All right. So, if we want to take Mary, not even
Out the window.
2 seconds into the, there we go. So, as you can clearly see,
Yes.
That's kind of depressing stuff.
Do you want us to write down the score too?
that's it, we're fighting it.
What's real about Fight Club?
I just finished that book again.
It's a book.
Yeah.
Before it was a major motion picture film. Oh, major motion picture.
The major motion picture.
You know what? Let's hold on. Let's. You know what? This is.
Already off track.
I'm changing my mind. This is all calculus, blah blah, that we don't need.
Yeah, who wants calculus?
Okay, so get rid of this. Here's what's going to happen.
I wrote it.
You go to take the limit of a rational function. Rational function meaning what?
It can reason with you, like, properly.
Right. It has no mental instability. Good. So you've got a function that has no mental instability, and you end up with something called an indeterminate form. We're going to do 2 indeterminate forms today. We'll do 3 or 4 tomorrow. If that happens, then you have a simple approach. And that simple approach is take the derivative of the top, take the derivative of the bottom, and do it again. That's it. Okay, now where are you going to screw up? Some of you are going to do a quotient rule. This is not a quotient. It's derivative of the top over derivative of the bottom. Okay, so I was going to give you a bunch of calculus speak in there that says if this exists, if it's an indeterminate form, you take the derivative of the top, derivative of the bottom, do it again. Take the limit again. If that doesn't work, do it again. And this goes on and on and on and on. So it'll make more sense if we dive into an example. Let's pretend I can actually see this. Limit as x approaches 0 of, oh, you know what? I'm not even going to tease you. I'm going to go right into some trig. ¿Por qué no?
Societo.
Talking smack. Bad enough she's talking smack, but then she's got to do it in a foreign language.
Sorry.
That's a minute.
Yeah, I got it. Yeah, I know. That's why she said lo siento, because I know what she's talking about.
She said calculus stupid.
Sorry.
Stupid.
Okay, plug and chug, what do you get?
Limit is x approaches 0, -3 sine x plus 5 over 2. Oh, plugging in 0.
Why? Yeah, well, what happens to the numerator?
So, you have to plug in 0.
Sure.
Or do you take the
It's 0. 0 over 0.
Okay, good. First indeterminate form, 0 over 0. If we get 0 in the denominator, then we're just back with what we did in chapter 1. That's just a plain old limit. You got to figure out other ways to do it. If we get 0 in the numerator, it's still just 0 over a number, which is okay, which is what's 0 over a number? 0, so we're okay. We go back to chapter 1. This is something new. That's our first indeterminate form, 0 over 0. Okay. You must check that every time with L'Hopital's. You can't just automatically assume that every problem I give you is going to be L'Hopital's from this point on, and you just L'Hopital the crap out of everything. Okay. Therefore, we apply L'Hopital's rule. Take the derivative of the top. Read it.
-3 sine.
Yes.
What's the derivative of the top?
-3 sine x plus 5,
And the bottom?
2.
Outstanding. Do it again. What do you get? Max?
3 cosine x.
No. Plug and chug again is what I meant.
Oh, it's plugging. Oh, okay. I was just 5 over 2. Oh, crap. Never mind. Wait, sine 2. That's 1. Yeah, so it's 2 over.
Oh, because
Sine of 0 is 0.
5 over 2, yeah.
You were right the first time, and then you
I got.
took yourself to a dark place
I
there.
thought I was wrong.
No.
Okay.
A little bit of self-confidence. Okay. Anything difficult about that? No? Not yet, of course. There's always a catch. Example number 2.
What's the point of us doing that?
So how many, what if it's still 0?
You can ask.
Indeterminate form. Today, just 2. Tomorrow, more. Well, one day more. Madden. No español, por favor. Okay, that's good. I'm right. Ben, your turn. Plug and chug, what do you get?
0, 0.
Are you sure?
Yeah.
What's e to the 0?
1.
1? Excuse me. Good, I'm just messing with
Because
it.
I
Good.
remember raised to the 0.
And the cosine of 0 is,
It is 1.
so you get,
1 minus 1.
which is
0.
good. 0 over 0. Now we apply L'Hopital's. Ben, what's the derivative of the top?
Is it 3e raised to the 3x minus 3e to the raised to the negative 3x over sine sine of 5x. 5 sine of, I don't know.
-5 sine of 5.
Positive. Because
It's positive?
Yeah.
Why?
Because it's a negative.
Oh, are you sure, Oliver?
Yeah, sorry.
Oh, okay.
Using with a 5.
How easily he swayed.
That's because.
Ben, do it again.
Cool. Cool. So that's, the top would be 3 minus 3. So that's 0.
Yeah.
We got that. And then, oh, yeah, it's 0 again.
0 over 0?
Yeah.
Oh boy.
Do it again. It's never bad.
Ben,
How's it going?
it's going well, thank you. Do it again.
Okay, 9e to the 3x, raised to the 3x, plus 9e to the raised to the negative 3x, over 25 cosine 5x. Negative.
Still less.
That's negative, right? No? I can't convince you it's negative?
You're the teacher, you should know this.
Well, what makes you think I don't know it?
It's not negative because the derivative of sine is positive.
Okay, all right. Plug and chug?
That would be 18, no, yeah, 18 over, because, yeah, 18 over 25.
Well done.
So basically, if you keep getting like an indeterminate form, you just keep going.
What if you like keep going like 6 down? It's still
Then you may have to come up with another approach. It is conceivable that you could get a function where as you continue to L'Hopital, it becomes a cyclic function and just keeps doing the same thing over and over again. Like for instance, you'll notice that no matter what we do, that e to the 3x is always gonna be there. If I had an e on the bottom too, it's always gonna be there. And so then we may run into a problem. Senor?
Like actually, why is it, why we do this now?
Oh, you're asking the question that I said that you would ask?
Yeah.
Right, and what would my response be?
I've been hiding it from you all this time, now I will tell you the answer.
Right. So you're gonna go with the sinister plot approach?
Yeah.
Yeah, I really don't know why.
Okay.
One of the reasons is because it involves taking derivatives, and we did limits before derivatives. And then we don't really ever come back to limits until we get here. So we've come full circle.
Wow.
Nice.
It's not a circle of life, it's just full circle.
Full circle now.
Of life.
It's a circle
Yeah,
of calc.
full circle of calc life. All right, let's make things a little more interesting.
Spice things up there.
Nice. That's all good start.
Oh, yeah. Sid, plug and chug.
Zero.
Sid, that might be off a little bit. Let's back up, shall we? Sid, what's the natural log of infinity? Shh. Sid, visualize in your brain the graph of the natural log.
Infinity.
Good. Thank you, Brett. And what's the square root of infinity?
Infinity. No.
Why was that one?
Yeah.
Yeah?
Yeah.
Yeah. Second indeterminate form, infinity over infinity. L'Hopital still applies. You ready, Sid?
Yeah.
Okay. Indeterminate form, moving forward, we want to take the derivative of the top, the derivative of the bottom, and then see what other kind of mess we can get into. And remember, It's derivative of the top, derivative of the bottom as separate functions, not a quotient rule
Product
or a product rule. All right, Sid,
Oh.
what's a
Oh.
derivative?
Go
Don't
ahead.
even let me finish my question. God, you're so
Go ahead.
yearning for learning. What's the derivative of one of? I don't even know what I'm asking. I almost told you the answer.
7.
All right, never mind.
Urinate.
I'll give you that one, Sid.
Yeah.
What's the derivative of the bottom?
Half x over negative half.
What?
Wait.
I think you're there. Kinda. In some sick and twisted way, I understand what you're saying. I think what you meant was that?
Yeah.
Okay.
My bad.
Yeah.
Yeah.
I don't
I
know.
got the answer.
Because I got a negative
The
1/2. I got an x out of there. I figured he was putting that all together.
Isn't it?
To make a...
Could you simplify that to be 2 square root of x over x?
I'm going to. That's my next step. Before I plug and chug again, because I don't really want to do 1 over infinity and all that other stuff, I'm going to clean that fraction up a little bit. So this becomes, I'm going to come over here, the limit as x approaches infinity of, I'll leave that alone, and then the bottom becomes 1 over 2 square root of x. So therefore this becomes a limit as x approaches infinity of, and dividing is by multiplying by Is that what you said?
Yeah.
Good, we're on the same page. Sid! Plug and chug. What's the square root of 2 times, what's 2 times the square root of infinity?
Infinity.
Sid, what's infinity?
Infinity.
Good job. Oh, look, another indeterminate form. What shall we do? What shall we do?
Cry.
Good. Option 1, cry. Option 2, Sid?
I don't know.
I don't know.
Sure you do.
You don't know or you don't want to know.
Right.
Should I do it again? X to the negative half.
I like it.
Yep. And 1.
Beautiful.
Infinity.
Yeah. So do you want to plug and chug or you want to simplify first?
Simplify.
I like simplifying too. Kind of sounded like a Marine there. I thought you said simplify. Simplify. Never mind. Sid,
Yeah.
plug and chug. What's 1 over infinity?
0.
0. Denominator gets very, very big. Fraction gets very, very small. Mark?
The last step would be to simplify.
Say again, I'm sorry.
Not on the step before, we just did simplify.
This guy?
Just go to the first one.
This one? Yeah, I probably could have. Could have gotten it here too because square root of x over x is x to the 1/2 divided by negative 1/2. So we would have gotten there too. Yes, Sid?
Are you recording this?
Yes, why?
Oh, never mind.
So we can listen to it over.
You want to go home and listen to yourself doing a Marine cheer? Or?
No, not really.
No, you
No.
just want to do whatever it takes to get it deleted from. I understand. I understand. You want to erase all existence of this video? Okay. Time for you to try one on your own. It's gonna be fun. Truer words were never spoken, Ben.
Gotta brush up on these privileges.
Whoops. Typo.
Hey, look at your glasses. Look at your glasses.
Whoa. That's cool.
Oh,
Just focus. You're focusing on 0.
Okay, try that one.
Oh, yeah, which is just if you divide infinity by two, it's
Oh, yeah, you're right.
yeah.
Wait, do you need to keep going after this?
Yeah.
It's no longer an indeterminate form.
What do you mean by indeterminate?
Zero, zero, infinity over infinity.
I think I did it.
Sam, what do you got?
I got infinity.
Anybody else get infinity? All right, talk us through it.
Okay, so it would be 3e to the 3x.
Wait, hold on.
And then you get infinity.
All right, there we go. Plug it in first. We figure out that it's an indeterminate form. Yes, I will want to see that. All right, back to you.
And then 3e to the 3x over 2x. And then that also gets infinity.
Uh-huh.
And
Let me
then-
interrupt you for a second. So you'll see what's happening here. The numerator is always going to have an e to the 3x in it, but as we progress, the degree of the denominator is decreasing until eventually you can see that in the next step, we're going to get something that will solve the problem for us. Go.
9e to the 3x over 2. That's infinity over 2, which is infinity.
Good. This is no longer an indeterminate form.
If we're taking a test, can we skip, like, if we realize what's happening, can we skip, like, the middle step? and just-
I would show it just to be sure.
Okay.
It's a good habit to get
Just
into.
in case.
That's good.
I said just in case. Nothing.
Just in case.
Yeah.
I had him in class last year.
Yeah, Justin did, yeah.
Yeah, he's a good guy.
He just doesn't show.
One more example, then we're done. Let's use,
I was asking if you interfered.
No, I haven't studied Justin yet, I'm just gonna go in blind.
You wouldn't have to.
Yeah.
Okay, go. You okay? You look like you're gonna throw up. Excuse me. It never gets old.
If there's no
It's custom overdose, there's no way you would, there's no way you would.
when you take two.
For my son.
You wouldn't believe the things I do.
Size 13 is for my son.
That's right. He's a beaut.
Wait, what is that?
Like I go into McDonald's and request Happy Meal toys. They just had Lego Batman. Collected the whole set.
I need a refresher. You get $100.
You can't just buy the toy. All right, what do we got?
Zero.
I got one.
1, 0, 1. How many got 1?
What?
How many got 1?
Wait, yeah, I got
0? Oh boy. Okay, let's start with the ones, people. Mark, how'd you get 1?
You take the first derivative,
Okay.
and you get 2 over 0.
Wait, hold on one second. Okay, so you took the derivative of the top and got what?
E to the x plus e to the negative x over x minus. Oh, I'm sorry, that's the first thing. And then e to the x minus e to the negative x over 2x.
Okay, good.
0 over 0.
Okay.
And you can't do that.
Okay, so then went to the next step.
And e to the x plus e to the negative x over 2.
gives you,
Didn't check it at the beginning.
Cause like 1 plus 1 is 2. So then it's 1.
wait, e to the 0 is 1, e to the negative 0 is 1, so you get
2 over 2.
2. Oh, there you go, because 1 plus 1 is 2, which is 1.
So,
Okay, makes perfect sense. However, just for discussion purposes, let's take a look at the people that got, what did the other people get? 0?
0.
How'd you get, oh wait, hold on,
Doesn't matter.
got a quick question.
the keep reading the data, it's 2 over 2.
I said that.
So,
Hold that thought for a second. Patrick?
in this case, you did not show that it is equal to whatever. So,
Just
do
2 over
you
0.
have to do that, or?
Yes.
Undefined.
This is not correct, because you missed one important thing. All of you that got 1, you forgot to check this first problem. That's not an indeterminate form. It's 2 over 0, that's not an indeterminate form. That's 2 over 0. So then we have to find a different way to get it. My point being, you need to check even from the get-go to make sure that it's either 0 over 0 or infinity over infinity. If it's not, then L'Hopital's rule doesn't apply. Pregunta.
Are those the only two indeterminate forms?
For now, yes. Tomorrow, or Monday, I've got like 3 or 4 more for you. How do you really do this one?
Fine.
Excuse me.
Split the fraction like gas axes.
You could split the fraction. That'd be 1. No, that ain't gonna work. I did it. Idea, Raj?
Can you check left and right words?
You probably could. That might work. I didn't do it that way. I mean, that might work. So put in a number a little bit bigger than 0 and a little bit smaller than 0. Check to make sure they're the same number. Possibility. I did it by rewriting it the following way, which I don't know if this is the most efficient way to do it, but it worked for me. Which is kind of like splitting the fraction. I took the denominator out and did it as a separate limit. Then do those as 2 separate limits. Okay, so what's the left limit? Well, that's just a plug and chug. 2 times, what's the right limit? Which is? When we're taking a limit, we can figure out what the limit is when we get 1 over 0. What happens when the denominator gets very, very close to 0? What happens to the fraction? It goes up. How high? Infinite. Okay, so remember, when we're talking about limits, if we get 1 over infinity with respect to limits, that's going to approach 0. And 1 over 0 is going to approach infinity. Now, is 1 over 0 infinity? No, but we're talking about limits, so we're talking about as we get very close to that 1 over infinity. So 1 over 1, 1 over 0.1, 1 over 0.001, 1 over 0.0001, et cetera, denominator gets smaller, fraction gets bigger. Senor?
So why did we bother to do all the splitting when we could have just done that when we had 2 over 0?
When we had 2 over 0.
Yeah.
Because you said 2
It's like 1 over 0.
Oh, in the very beginning?
Yeah.
It's a great question.
You just want to show us.
It's a great question.
How you get there.
Yeah, because the very first step is 2 over 0.
Yeah.
Yeah. Did you see that? You saw that, right? Was that a condor or a pelican? What just flew over? Oh, yeah, you know, sorry.
Wait, what happened?
This huge bird just flew up and landed on the...
Yeah, I saw it.
I actually found the bird in the classroom. Yes.
What kind of bird?
That real large.
What kind of bird? I don't know what it was.
Bald
eagle or a falcon or something. I left the windows
Kind of
open.
like go like a
All day?
Were there not screens or something? Or
No, back in the old days we didn't have.
You didn't go all bird crazy and destroy the window?
I was just like fly around. So I just had to leave all the windows open until it flew out. Just hear that or go at it with a tennis racket. I opted for the former, not.
Go ahead to the gym. You ever seen the guns?
Okay, so 0 over 0, infinity over infinity. Must check indeterminate forms before you start doing L'Hopital's rule. Tomorrow we'll look at 0 times infinity, 1 times infinity, 0 raised to the infinity. I don't know, I got like 4 or 5 of them.
Oh, it's fun. It's on top
Fun
of
way.
the big pine tree.
What type of car is that?
I see.
I don't see any. It's on top of the tree.
I think it's a python.
I'm gonna open the window.
No, that's wrong.
Definitely a Jaguar.